Hello everyone, welcome back to Serica's Math Made Simple. So in today's lesson, we are going to be deriving the Ohm's law formula given by V equals IR. So today's lesson focuses on deriving the formula V equals IR, and this is the Ohm law, right? The Ohm's law states that the current that is flowing through a conductor is directly proportional to the voltage applied to the conductor, okay? And that law is given by the relationship V is equal to IR, where V is the voltage applied to the conductor in volts, I is the current flowing through the conductor in amperes, and R is the resistance that opposes the flow of current in that conductor given in ohms. So have you ever wondered where this formula comes from? Let's find out where this formula actually comes from and how it was formed to be V equals IR. Okay, so Ohm law again states that the current that's flowing through a metal or conductor is directly proportional to the potential difference or the voltage applied to that conductor. Now, mathematically, this law can be expressed as, the Ohm's law can be expressed as, in mathematical terms, we can express the Ohm law as V is directly proportional to I. Okay, so this is the mathematical expression of Ohm's law, which states that V, or the current flowing through a conductor, is directly proportional to the voltage applied to that conductor. So V is directly proportional to I. This sign here is the sign of proportionality, okay? And there is something about the sign of proportionality. Whenever we introduce the sign of proportionality, there is a condition that is attached to it when we are taking it off, okay? So because I varies as I varies, we use the constant of proportionality. Now, if we are to take off this constant of proportionality from this relationship, we need to introduce a constant. And in this case, this constant is R, the resistance. So since V is directly proportional to I, removing the constant of proportionality, we will have V is equals to I R, where R is the constant of proportionality, and in this case it is the resistance which opposes the flow of current. Now, I want you to understand that if we are to plot a graph of V against I, something like this, if we are to plot a graph of something like this, of V, this is our V, we can call this our V, and our I here. Now, if we plot a graph of V against I, we will have straight line, okay? And this straight line indicates that the relationship between V and I is a direct relationship, meaning that as V increases, I also increases. Now, according to the relationship V is equals to I arrow, this would mean that if we calculate the gradient of this graph at any point, the gradient of this graph at any point, okay, is going to give us S, which is a slope, is going to give us R, the resistance. So according to the relationship V equals I arrow, if we plot a graph of V against I and calculate the slope or the gradient of that graph, the slope of that graph is going to be S equals to R. So in essence, we are saying that whenever we have a relationship as this, whenever I have a relationship given as this, something like A, whenever I have a relationship given by A, let's say A is equals to KB, where this K is a constant of proportionality. If we draw a graph of A against B and we calculate the gradient of that graph is going to give us K. Okay, so it's from this concept we have V equals I arrow, where arrow is the slope. If we plot a graph of V against I, we are going to have arrow as the gradient, and it is the resistance that opposes the flow of current. So this is where this formula came from, and this is how it was formed. The formula, the famous Ohm's law formula, V equals I arrow, which we know today, came from this mathematical manipulation. Is that okay? So thanks for watching. If this video helped you understand something, make sure you like, you comment, and you share so others can learn too. See you in our next lesson.